Hey guys, this is the 6-5 notes, and I'm going to call it part 1 because we have a part 2 to this that's going to come the next day. So we're just going to go through some of this today, and you'll see where I stop later on, and leave you with that. So starts off on this page here before 6-5, we just got a bunch of radicals, and these radicals are split up. We've done this stuff before. On the left, we have even roots. And on the right side, we have odd roots. Okay. Remember, one of the key things with even roots is that with our answers, we're thinking plus or minus, versus with odd roots, it's going to be one or the other. Okay. Such as even roots, let's say you have square root of 4, your answer is plus or minus 2. Or with odd roots, let's say you have the cube root of 8, your answer is just positive 2, right? So there's just, your simple breakdown. With that stuff in mind, let's take a look at what we have here. The first one, I'm going to go down the left-hand column first, looking at just the even roots. We have the square root of x squared. Below that's the square root of x to the 4th, x to the 6th, x to the 8th. It's a bunch of square roots, so it's a bunch of even roots, right? First of all, the square root of x squared. Well, hopefully by now we know that that equals x. And like we've talked about, since it's an even root, we're thinking plus or minus. Now, one way that you're going to see us account for that isn't always with plus or minus, rather with absolute value bars. Okay? So in the same way that plus or minus accounts for the positive and the negative, so will the absolute value bars here. The next one down, the square root of x to the 4th, that's going to be x squared. And again, another way to think about that is you have x to the 4th to the 1/2 power, and then you multiply 4 times 1/2. Now, like I said above, we're going to need to include absolute value bars around that. Okay. After that, square root of x to the 6th, well, x to the 3rd, and an even root means absolute value bars. And then square root of x to the 8th, x to the 4th, with, again, absolute value bars. Okay, so there's our even roots. Odd roots, we don't need the absolute value bars, right? Because it's just one or the other. So the first one here, the cube root of x to the 3rd is just x, right? That's like saying x to the 3rd to the 1/3. And when you take that 3 and 1/3 and multiply, you're going to get 1. Okay, how about the cube root of x to the 6th? That's going to be x squared. And the last one, cube root of x to the 9th, is going to be x cubed. Okay, so again, this should look familiar. This is like a little warm-up for us here. Get us rocking and rolling into this section. Let's go ahead and flip the page to where it says 6-5, solving square root and radical equations. So first of all, a radical equation, that first line there, is when there is a variable in the radicand or as the base of an exponent. So think of something like this. Say you've got the square root of x minus 1, okay? That would be your variable in the radicand. Or if it were the base of an exponent, that same thing can be thought of as x minus 1 to the 1/2 power, right? Okay, so that's kind of what we're talking about here. Solving these types of equations will often have us square both sides of an equation. So maybe underline that or something, highlight it, square both sides. It's going to be a key thing we're going to do here a lot. And as it says in parentheses, this will eliminate the radical. How does that work? Well, let's look at example 1 here. Square root of x equals 4. Now, like I just said, if we square both sides of this thing, so square the left and square the right, then on the left-hand side, the square root of x squared, that just cancels itself out, right? The square root in a square, boom, that's going to become just x. So we're getting rid of the radical here. And so this thing will turn into x equals 4 squared, which is 16. Okay. Another way to think about that, again, is turning that radical into exponents. So I had the square root of x, which is x to the 1/2, and when I square it, that's just going to equal x, right? 1/2 times 2 is 1. Okay, how about the one to the right? 3 plus square root of x equals 19. Same idea, except now first I want to subtract 3 from both sides. So now I've gotten the radical by itself. Now I can go ahead and square it. So when I square the left and the right, x is going to equal 16 squared, which equals, anyone? 256. Okay. Let's go down to the next one. Back to the left side now. 3 plus the square root of 2x minus 3 equals 8. Well, kind of like we did before and got that radical by itself, I'm going to go ahead and subtract 3 to get that radical all by itself here on the left. So we got radical 2x minus 3 equals 5. 8 minus 3 is 5, right? So now we got the radical by itself. Let's go ahead and square it. All right, when I square the left, the radical goes away, leaving me with just 2x minus 3. When I square the right, 5 squared is going to give me 25. And now look at that. It's a nice little easy two-step algebra problem, right? We're just going to add 3. So 2x equals 28. Divide by 2. What is x going to equal here? 14. Okay, good. And let's do one more. Over there to the right, we have the square root of 4x plus 1 minus 5 equals 0. Again, let's go ahead and get that radical by itself, which means I'm adding 5. So I got that. Now we got a radical, so I want to square it. So let's go ahead and make this 4x plus 1 equals 25. And now we just solve, right? Using basic algebra. Subtract 1. 4x equals 24. Divide by 4. X equals 6. Okay, pretty easy so far. The key here, okay, look what I wrote down there. The key with all of this is to isolate the radical first. I know I just said that a lot. Isolate, remember, if you don't remember what that word means, get by itself. So that's when we were adding or subtracting these numbers from the left over to the right so that we can get the radical by itself. Then we can simply square it and solve. Okay, what about this one? This one's a little different because we're not taking a square root. We have 3 times x plus 1 to the 2/3 power equals 12. So this one's a little weird. Or another way to think about this, 3 to the cubed root of x plus 1 squared equals 12. Maybe if you prefer to look at that as a radical. Either way, it's the same thing. What do we do here? Well, the first step should be pretty easy, right? I think you guys will all see that we're going to want to divide by 3 right off the bat. So when I do that, that's going to take me down to x plus 1 to the 2/3 equals 4. And I'm going to choose to keep this with exponent form. Okay, I'm going to choose to keep it to the 2/3 power. That's just going to help me realize my next step. So if you think back to up top, right up here, I'm going to draw a little like bubble or something around this. The whole idea was when we had x to the 1/2, we took the left side to the second power. And what that did for us, or by our powers of exponents here, our properties, we're going to multiply those things so that way we're going to get an exponent of 1. So we just got x to the first, right? We don't put x to the first, we just put x. But the whole idea is I want to raise it to something so that I can get to the first power. Similarly, if I had the cubed root of x, I wouldn't want to raise that to the second power. I would want to raise that to the third power, because that would take me right to x. So, same concept down here now. I have x plus 1 to the 2/3 power. I don't want to raise that to the second or to the third. I want to take that whole side to the reciprocal, to the 3/2 power. And then what I do to the left, I also have to do to the right. So 4 to the 3/2 power. That's what we just did above, right? 1/2 to the second, 2 is the reciprocal of 1/2. 1/3 to the 3, 3 is the reciprocal of 1/3. Okay. Now the reason we do that, like I said, when our properties of exponents here are going to make us multiply, and 2/3 times 3/2 is going to equal 1. So my next step looks like this. X plus 1 equals 4 to the 3 halves. Now 4 to the 3 halves, man, a couple ways I can think about that. I'm going to go ahead and choose to write this as 4 to the 1 half to the third. I find that to be the easiest because I know 4 to the 1 half power, that's the square root. 4 is a perfect square. I know what the square root is of that, right? So this is going to get me x plus 1 equals the square root of 4, which we know is plus or minus 2, to the third power. Okay? Now I really am emphasizing that plus or minus here, like we know even roots, right? Plus or minus, because what we're going to get are two answers. One for when it's positive 2, and one for when it's negative 2. So I've got x plus 1 equals, we'll do the positive side, positive 2 to the third power. And then the other option is x plus 1 equals negative 2 to the third power. And the reason, again, the reason there's two answers here is because we originally took an even root. Okay, 4 to the 1 half was my even root. So I've got my two answers I'm working with now. Let's go ahead and solve. This really isn't too difficult, right? We got x plus 1 equals 2 to the third, which is 8. So x equals 7 for the first answer. And on the right, I got x plus 1 equals negative 2 to the third. That would be negative 8. Subtract 1, x equals negative 9. So my two answers here, 7 and negative 9. Now, it does tell me over here that I'm going to want to check my solutions. We've done this before earlier in the year, right? Checking solutions. So I'm going to want to check, first of all, when x is 7. And so that means I'm plugging 7 in for x to the original equation. That'll give me 3 times 7 plus 1, which is 8, to the 2/3 power. And hopefully that equals 12, right? Just plugging into my equation. So I get 3 times something equals 12. 8 to the 2/3. If you could do that on your calculator, that's one way to do it. Think about it also as 8 to the 1/3 squared. 8 to the 1/3 is 2. 2 squared is 4. So does 3 times 4 equal 12? Yes, which is good. That answer is valid for us. Now I got to check the other one when x equals negative 9. Okay. So we're plugging it in to 3 times x plus 1. Negative 9 plus 1 is negative 8 to the 2/3 power equals 12. Okay. Negative 8 to the 2/3, that's also going to equal 4. So 3 times 4 equals 12. Boom. We are in good shape. Okay. Hopefully you're doing all right so far. We're going to do just one more thing on the next page, so go ahead and flip it over to page 3. We got this last one here that looks a little crazier, a little more elaborate. It's 3 times the 5th root, x plus 1 to the 3rd, plus 1 equals 25. First step, subtract 1. 3, 5th root, x plus 1 to the 3rd equals 24. Then, let's go ahead and divide by 3. So 5th root, x plus 1 to the 3rd equals 8. Now I'm going to flip this radical form around on the left. I'm going to put it in exponent form. That's going to help me visualize what's going on. I have x plus 1, this is going to be to the 3/5 power. And so now I know that I need to take each side to the 5/3 power. So when I raise each side to the 5/3, on the left, I get just x plus 1. And on the right, I get 8 to the 5/3. Okay, how do we think of 8 to the 5/3? Well, I'm going to break that down into 8 to the 1/3 to the 5th. X plus 1 equals 8 to the 1/3, which is 2 to the 5th. So x plus 1 equals, anyone know 2 to the 5th? That would be 32. And then subtract 1, x equals 31. Okay, I know I went through that kind of quick. I just want to make sure you get to your homework. That's all we're going to do for today. Okay, Your homework is the worksheet in the packet, 6-5 worksheet, okay?